Okay, so in this problem, what we're going to do is we're going to figure out the speed with which a satellite must be placed above the Earth in order for it to move in a circular orbit. Okay, so what we know for the Earth is that the radius of the Earth is 6.38 times 10 to the 6 meters. The mass of the Earth is 5.98 times 10 to the 24 kg, and we're going to figure out, let's say that we're going to place a satellite at a height of, at an altitude of let's say 1000 kilometers above the Earth's surface, and we want to know, in order for it to move around in a circular orbit, what should be its speed. And we can also figure out the time period for this orbit. So we'll define the speed and the time period. Okay, so from the previous video, you already recognize by now is that the speed of the object is simply equal to square root of g times m over r. Okay, and in order to obtain this, okay, let's just quickly do a calculation of this. And if you cannot remember this, it's always good to know how you get this. And we're using the fact that the force, which happens to be the force of gravity, which in this case, which is capital G times the mass of the Earth multiplied by the mass of the satellite divided by r square, and this is equal to mass of the satellite times v squared over r. Force, some force is equal to the centripetal force. This is the centripetal force, and then this is, this is the force that is responsible, the force responsible for it. Okay, so some force is equal to the centripetal force, and so we end up getting V equals square root of G times m over r. Keep in mind that G is a constant, and G has a value of 6.67 times 10 to the minus 11. Capital M is the mass of the central object. Remember this, capital M is mass of the object that you're going around. Okay, it's the mass of the central object. It's not the mass of the satellite, it's mass of the object. So in this case, capital M is the mass of the Earth, which is 5.98 times 10 to the 24 kg, and r is the radius. Now in this case, make sure that you understand that r is the distance all the way from the center of the planet to where the satellite is. So it is not just 1,000 kilometers, but it is the radius of the Earth plus the 1,000 kilometers. And so we have 6.38 times 10 to the 6 plus 1,000 times 10 to the 3. Okay, because a kilometer to meters is 1,000 times. So this gives us 7.38 times 10 to the 6 meters. Okay, so we have all our pieces. Let's figure out the speed. The speed V now is equal to square root of 6.67 times 10 to the minus 11 multiplied by 5.98 times 10 to the 24, and then you divide this by 7.38 times 10 to the 6 meter. Alright, so it's very straightforward to do this. Now here's a simple advice that I would have for you guys. As you're doing this, try not putting everything in your calculator once, or if you want to do that, okay, please make sure that when you put your denominator in, just put the denominator in parentheses. Do not just do 7.38 and then have the 10.6 just hanging around somewhere, because you will typically make mistakes, and I've seen way too many people make way too many unnecessary mistakes with this. This is a simple calculation. Keep it simple. The way I'll do it is I'll find the numerator first, divide it by the denominator, and then take the square root, and I'll write the answer. Okay, so just make sure that so the numerator ends up becoming 3.98 times 10 to the 14, or 3.99 times 10 to the 14, divided by 7.38 times 10 to the 6. Okay, so now we can divide by 7.38 10 to the 6, and that gives us a value which is 5404683. Okay, and now I have to find the square root of that, and that gives me 7351 meters per second. Great, we have the speed now. Once we have the speed, we can find the time period using the relation t is equal to the circumference divided by the speed. Okay, the circumference is equal to 2 pi times 6.38, my mistake, 7.38 times 10 to the 6 divided by the speed, which is 7351, and you end up getting 5453 seconds. Okay, you can convert this to hours, and it'll be about, you know, an hour and a half or something like that. Great. So again, the process is very simple. Just make sure that you calculate all the parts correctly. Use the expression. If you do not remember that the speed should be square root of gm over r, just make sure that, you know, go through the derivation. It takes about 20 seconds to do the derivation. The force is equal to centripetal force, you get V, and then just make sure that you know all your terms. The capital M is the mass of the central object, the R is the radius of the entire circular path, which means in this case it happens to be the radius of the planet, okay, plus the altitude, and then you plug it all in, everything comes out nice and easy. Great.